looked at the ability to use pivot tables and pivot charts to look at distributions for different variables and that we are interested in for our analysis. Another important thing to do is to look at different averages and to be able to quantify savings for different fuel types, for different buildings, and different ranges. We have to take into account that the way the data is set up is that these are weighted, they have weights to them. So that's why we would have to use a weighted average. However, if you would notice here and column C, the weights are uniform. So you could just do averages on their own. But I will showcase as well the case where if we have different weights for the data set, how we could do that as well. So let's look into that. Let's take a case where we're looking, for example, at savings for electricity fuel type for our buildings. So JA here, output electricity with savings, would be the first one of those. And the final one would be, in this case, JX, which is out electricity. You can see that's the last one. They are put in sequence. And then JY would be for the fuel oil. So we have JA to JX is what we want to look at. So let's take a column here on the side and start creating a new column that we would like to do some calculations on. So let's look at the total itself. So let's look at let's indicate total savings per electricity per building. In this case, we would just simply use a simple Excel formula to be able to do this. So we will sum all the values in the rows or the columns that go from JA to JX per row. So effectively, in this case, we have JA2 to JX2, and we enter. We have our first one. In the interest of just time and showing you, I will limit this to, let's say, the first 40 or 30, 31, and in that case, 39, apologies. These are the summations of those. So when we look at that one, we have that. Now that we've calculated those sums, we could do is simply calculate the average of all of those. So we could do a bunch of operations. We could do effectively, first of all, the sum. So look at the total of the savings that we're getting for electricity on its own. That's if you want to look at the total savings per fuel, if you calculated it this way. And let's kind of call that, say this is the sum, or if you could say total savings per fuel. This is, we know what we're doing here. And let's look at the average savings per dwelling. And in this case, let's as well extend that to this case and calculate the average. The average itself is going to be taken from here up to here, and then we calculate this particular average. So in this case, these 40 values would be equal to 618.445. But the way we've done this is we have not taken weighting into account. So this is something that if you want to do, the way to do weighting in account is that we could create something else here, which is we can copy this name and over here just add the indication that this is weighted. Weighting can occur by literally multiplying this number over here with the actual weight of that particular building that we're using and how much it represents within our data set. So in this case, we could literally just do MM2, which is representative here of this particular row, times C2. C is the column, as I referred to earlier, which is the one that has the weights that we have. These are the numbers here. And we could just use the flash fill ability to be able to just do what we have up to the same to 40. These are the new ones. In this case, if we do summation, we're looking at the total sum of those as per the weighting occurs. So if this is representative of 242 samples, or 3 samples or 4 samples, depending on the weight, this is what we're looking at as a total summation of savings according to how much this building would represent in that particular community or data set that we're looking at. However, if we look at the averaging of those and come here and we average and we take this out of the way, right, we get this number, which is 149,744.932, which is of course higher than this one. However, since all the weights are equal, just to kind of showcase how that would work, what we could do is we could take this number over here, which is MN, and let's just do this calculation to show you. MN 42 and actually 43, apologies, divided by C 43, which is, again, since they have the exact same weighting distribution and we have the exact same average here. This is just to showcase how if we had different weights, however, this would be a different number, but since they're all uniform, we just confirmed that both of them work at the same time. So this is how we would do both a weighted average and how we would do it on a regular one. We can also use functions like sum product if you want to look at it at a total average weighted average unit, but you don't really need to do that. You could just do it this way. Now, another area of interest would be looking at the interquartile range of what we have. So let's actually look at those. So let's kind of create something here, which is, let's say, quartile 1, and let's say quartile 3, and let's look at the interquartile range, which is the IQR. So Q1 and so the interquartile range allows us to look at the data between 75 and 25%, which is the first and the third one. So the difference between them would give us our interquartile range between the range of data that we have. So to do that, we could use another function here, which is effectively using an equal quartile. And actually, I think we do not use enter, just literally press on it if needed. Enter just cancels what we're using. And we have to look at the array that we're looking at. We can effectively actually select it over here, and Excel allows us to do something like that. So let's say we're doing these. We notice here. So we've selected the range of data that we're looking at. What we need to select now is which quartile are we looking at. So we're looking at the first quartile, 25th percentile. This is the one we're going to select here. And we add this one and close our brackets. And this is our first one. So for the second one, effectively, you could copy, if you like, the actual formula. And all you're going to have to do is change the quartile into the third one. So we have the third quartile, 75th percent. And we have those. And this is the third quartile of what we have. Our IQR effectively is just literally, it would be equal in this case to MQ11 minus MQ10. This is the difference between them. This is my interquartile range for this particular data that we have. You can apply this for the entirety of the 9,014 samples that we're looking at. And thus we could calculate averages, weighted averages if needed, depending on the data set that we're doing, and looking at the interquartile range, for example, in this case, for the total savings per fuel per building for the range that we've selected.